All right, so we were studying the parameters for linear regression. That means how to find the values of them. Okay, as I taught, y equal to mx plus c is your equation, linear equation, and the error is given as y dash minus y. Then we did square of it. Then we took summation of it. Then we divided it with the total number of samples that you call as mean square error, MSE. Okay, or you can say it as cost function or MSE. Fine. Then I substituted the value of y here, which I said it's better to write the equation in form of beta naught plus beta 1 x, where beta naught and beta 1 are the coefficients. You can say them as like slope or intercept. And I put the value of both in the equation. Okay, fine. So it's like summation y dash minus beta naught plus beta 1 x whole square divided by n. Okay, so this is your cost function or error, mean square error, whatever you want to say, you can. And the goal is to minimize it. Okay, I should have minimum error. Okay, so we took calculus concepts of differentiation, maxima, minima, and for that we have to differentiate this error. We got two parameters, beta naught and beta 1, and yesterday class we did solved for beta naught. Okay, that means I differentiated this error with respect to beta naught. Okay, and beta 1 I kept constant. Okay, then I equated it to 0 and found a value of beta naught. That was something like y bar minus beta 1 x bar. It was something like this. Okay, now we have to proceed ahead and look out for what could be the value of beta 1. Okay, so let's again take this error equation, e equal to 1 by n summation y dash minus beta naught plus beta 1 x whole square. Differentiate it with respect to beta 1. So del E by del beta 1 is equal to 1 by n. Let it be. First is the power differentiation. So 2 you have to bring it in front. So 2 summation y dash minus beta naught plus beta 1 x dot. Now you have to go inside the bracket to perform further differentiation. So it will be like differentiating y dash with respect to beta 1, that is 0, minus differentiation of beta naught with respect to beta 1 is 0. You are having beta 1, its differentiation with respect to beta 1 will be 1. X will be the term which is left. Okay, so minus 0 plus x. That's it. Okay, so you are getting del E by del beta 1 is equal to, so this minus sign, you are going to take it outside, minus 2 by n summation y dash minus beta naught plus beta 1 x into x. This is what you are getting. Okay, fine. So still my problem is not solved. I need to solve it ahead. And before that, we have to confirm the value of beta naught which we have calculated is this only or not. Did you remember what is the value of beta naught which we calculated yesterday? Is this like y bar minus beta 1 x bar only? Okay, let me take this thing from my side, that yes, it's that value only. So del E by del beta 1 is equal to minus 2 by n. Okay, so x is here now, summation is here. So summation x y bar minus beta naught plus beta 1 x, like this. And let me take this summation, let me take this x inside, like del E by del beta 1 is equal to minus 2 by n. Summation is outside, I'm taking x inside. So y dash x minus minus x into beta naught plus beta 1 x. Okay, let me multiply x inside again. So del E by del beta 1 is equal to minus 2 by n summation y dash x minus beta naught x minus beta 1 x square. This is what I'm getting. Now tell me, so far what I have written here in the equation, is it clear or not? Did you understood the steps? Please tell me. Okay, let me check what is your response. Yes, tell me. You understood all the steps because it is mandatory derivation for us right now. Okay, so yes, we are having these terms. Now, what you can do is, can we substitute the value of beta naught here? Can we substitute the value of beta naught here? Okay, let me um, take a chance that, or shall we take summation inside? Shall we take summation inside divide by n? This thing also we do have as an option. Okay, summation is still present outside. Okay, either we can put the value of beta naught here first, and then because we have to do something with the summation. Okay, fine. Let us suppose we are going to put the value of beta naught here. So del E by del beta 1 is equal to minus 2 by n summation y dash x minus beta naught, put its value what it is, y bar minus beta 1 x bar multiply by x minus beta 1 x square. Okay, this is what I'm getting. Okay, fine. Then what can be done? Now let me share my entire screen, and I have to use other pages to solve this equation. Okay, so here it is. All right. So I am having del E by del beta 1 is equal to minus 2 by n summation y dash x. Okay, then you are having minus y bar. Okay, minus y bar minus beta 1 x bar into x plus, sorry, minus beta 1 x square. Okay, minus beta 1 x square, that is what you are having. Okay, so let me open up the bracket. Minus 2 by n summation y dash x, multiply this thing, minus y bar x, multiply this thing. So minus, okay, it will be plus beta 1 x bar x minus beta 1 x. This is x square. This is what you are getting. Okay, this is what you are getting. Then what I can do is, let's take the summation inside. So minus 2 and also n, so I can make like average. So y bar, sorry, y dash, I can take summation of x divided by n. That is what I can take, summation of x divided by n minus y bar summation of x divided by n. That also we can do. Okay, fine. And then, okay, with these two terms I did, plus beta 1 x bar, if I take summation of x divided by n here, minus, I don't have anything to multiply, minus beta 1 x square summation 1 divided by n. Okay, summation 1 or summation of x square, I think that should be a better one. Summation of x square, like this. Okay, what do you say? We have to just, here, if I take like summation of x square by n, something like this. Okay, let it be. So minus 2 y dash summation of x upon n x bar minus y bar summation of x upon n x bar plus beta 1 x bar beta 1 x bar, then summation of x by n. Is it making again x bar? Is it making again x bar? Yes. So here now I think, what I think is, in this particular case, we are taking, okay, we are considering here summation n and all specifically for these two terms. Okay, I require these values x bar x minus beta 1 x square. That's what I'm expecting here. Okay, this is what my expectation is. I should get such values. Okay, where it's possible, I did combined to have summation divided by n and put them into the bar, whatever possible I did. Then here the things are getting like, if I say summation of x upon n, so it will be like this: minus 2 y dash x bar minus y bar x bar plus beta 1. Okay, this is already x bar, and this will also become x bar. Okay, so it will be like x bar into x bar, x bar into x bar. And what will happen here? This is x square, this is x square. So it will be okay, one I can take summation. Okay, because one summation is there, so I can do one thing: minus beta 1 summation of x by n and then multiply by x. And that's what I can do. That's what I can do. Okay, because it is x square now, so split it into x and take summation and divide it by n with one of the x. So one you just keep is as it is. Okay, and if I continue with the same process, minus 2 y dash x bar minus y bar into x bar plus beta 1, this is x bar into x bar, this will turn up into minus beta 1 x bar into x. So from here, if I think, I can take, okay, from these terms what I can do is minus 2, I can take x bar common from here, and I will get inside y dash minus y bar. From here also, I can take beta 1 x bar common, and inside will be x bar minus x. That's what I'm getting. I guess I can take entire x bar common from the entire, okay, from the entire this bracket. So minus 2 x bar, and here I'm getting y dash minus y bar plus beta 1 x bar minus x. That's what I'm getting. And if I say that my differentiation is equal to 0, del E by del beta 1 is equal to 0, what it will be? It will be like, okay, this is equal to 0. So minus 2 x bar y dash minus y bar plus beta 1 x bar minus x, this is equal to 0. So bring this down, so that will be equal to 0. And what I am available with, y dash minus y bar plus beta 1 x bar minus x, this is equal to 0. Okay, so bring it here on this particular side. So beta 1 x bar minus x is equal to minus of y dash minus y bar, and beta 1 is equal to minus of y dash minus y bar upon x bar minus x. Or I think it's a better way, because minus is coming, so I can change the terms. So it will be beta 1 is equal to y bar minus y dash को आप y just write it as y, don't no need to just give the notation every time. So y bar minus, okay, y bar minus y and x bar minus x, this is what I can write. And I guess slope is this thing only. Slope is this thing only, na? Y2 minus y1 upon x2 minus x. I think slope can be written in this particular format only. So here it is like y bar minus y upon x bar minus x. That's the slope. And if I can put the value of slope again, beta 1 in the equation, I can get the value of beta naught. Okay, so let me rewind you what happened. From here you started. You substituted the value of beta naught here. And then you started solving multiplication of x inside and all these things you did. Then you took summation inside. So I took summation everywhere. And here I thought that I should get such kind of terms. I try to ignore that. Is there any possibility that I can ignore summation and divided by n? So then I thought that how I can mathematically do that. So it's better I considered. Okay, and I put summation of x by n as x bar, and here I was having summation of x square. So I split it like x into x, and with one x I give one summation divided by n. That's what I did. So it converted into x bar into x. So this thing converted into x bar into x, and then I took common x bar from throughout. Okay, from throughout I took x bar common. This is what I get in the combinations, like these terms I got in. Okay, and then I put it equal to 0, and by putting it equal to 0 and further solving, this is what I am getting. Okay, so let me rewrite it. I got beta 1 is equal to y bar minus y x bar minus x. This is my beta 1. Okay, and then if I want to calculate what is beta naught, because beta naught is y bar minus beta 1 x bar. So if I put the value of beta 1 here, so it will be like beta naught is equal to y bar minus y into x bar upon x bar minus x. This is something I'm getting. And if I just like take the LCM, beta naught is equal to, let it multiply y bar. Okay, this is your y bar, multiply it by x bar minus x, and here also you are having minus of y bar minus y into x bar divided by x bar minus x. If I multiply these terms, what I'm getting, beta naught is equal to y bar into x bar. Okay, let me solve properly. Okay, so it will be like this into this. So x bar, y bar, then y bar x, then okay, minus of x bar, y bar plus y x bar. So okay, this is y bar x bar, na? Y bar x bar. So these two get cancelled, and here I'm getting x bar minus x. Something I'm getting like this. So beta naught will be like y x bar minus y bar x divided by x bar minus x. This is something I'm getting as beta naught. Okay, so if I do confirm related to the notes, okay, I do have the notes related to it for the linear regression. Okay, and let me show you that. Okay, ML nodes for linear regression, and yes, here is the slope calculation for it. Okay, so all these handwritten. Fine, we were correct. Beta naught was this thing, y bar minus beta 1 x bar. This was beta naught. Okay, and then we further solved for beta 1. Beta 1 we got it as here also. Here also we were like correct that y minus y bar upon x minus x bar. This is your beta 1. Either I can write y bar minus y upon x bar minus x, whatever. You can change it. So we were also correct here. Okay, fine. And there is one more thing which can be done is we can multiply x bar minus x numerator and in the denominator also. That's what they have done here. Multiply with numerator and the denominator. This this thing. Okay, so beta 1, we also got beta 1. So beta 1 we got, and we can put beta 1 here in the equation. In this particular equation we can get the value of beta naught, and just I have shown you what is the value of beta naught. Okay, in my calculation this is something I'm getting. Okay, so as I confirmed, beta naught was y bar minus beta 1 x bar, and beta 1 was y bar minus y upon x bar minus x. Okay, this is beta 1. Okay, fine. There could be some there could be some assumptions, there could be some solution tactics can be used. Might be you may see something different in some different derivations. I proceeded as simple, like it's all in front of you. Where I want to open up the bracket, I did. Where I want to take the summation, I did. Okay, so if you think that there is any change, or if any of the steps should be likely to be not here, and something else should have to be here, so you can tell. However, confirmed you this was the beta 1, this was your beta 1. Okay, beta naught and beta 1, and you can put this beta 1 here back again, and you will get something like this. Okay, fine. Now it depends. Other people will be like some in derivation. Either they are not taking summation or taking summation, or they are trying to solve with some different approach. Okay, so there could be a possibility, but things will be around this only. Okay, so what I found that beta 1 and beta naught, these two values are dependent upon the slopes. Like not this is the slope. Okay, this is slope. Mean. Okay, x bar and y bar are the mean, so they're dependent upon the mean. Okay, and with this regards only, I do have one example. Okay, with this regards only, you can check one example. Let us suppose this is your data set: sales and advertising. Okay, this much money spent on the sales, advertising, sorry, and this was the sales happened. Okay, so advertising is x, sales is y. You can apply your formula y equal to beta naught plus beta 1 x. X is advertising. Okay, fine. And now here we need to calculate the value of beta naught and the beta 1. We have to apply the same concept of regression, linear regression. So what you have to do is, what is required to find the value of x, beta naught and beta 1? The first step is find the mean of x and y. That's what they did. Step number 1, calculate mean of x and y. So you will getting x bar and y bar. Then calculate the error of each variable by the mean. Like this. Y minus y bar, x minus x bar. So that's what I did now. Okay. Y minus y bar, x minus x bar, or you can say that y bar minus y, x bar minus x. It's up to you. And then take the ratio of them. Take the summation of the entire terms and take the ratio. Okay. So take the summation of all the terms here also, and take the ratio. Okay. They have done this thing because just to multiply this thing in numerator and denominator. So if you want to ignore, you can. Okay. What you have to do next is just take the sum of all the values here also, and divide it. This will be your beta 1. Okay. This will give you the beta 1. So beta 1 here is coming to be like 25 point something. Okay. This is how the beta 1 is coming, 25 point something. And to calculate the beta naught, you very well know y bar minus beta 1 x bar. That's it. With the help of this, you can calculate beta naught. So the value of beta naught is coming to be like this, 7.23. Now you got the equation, y equal to 7.2 plus 25.3 advertising into advertising. Now you can put any value of advertising here, you can get the value of sales. Okay, got it. This is how we found the value of beta naught and beta 1, and this is how we can perform the prediction. We can make the predictions. Okay, you got this thing. Okay, and now this is how a model do prediction. So model in training na, it calculate the value of beta naught and beta 1 only. This is what we called as a training. And for prediction, once you got the value of beta naught and beta 1, put it in the equation again. And now if someone give you that this is the advertisement money we have invested, what is the sales, so you can find it. That's the working of linear regression. Okay, so the maths, the which I did in these two classes, that's very much important. The entire derivation of linear regression. Okay, and it holds for these two values. Okay, fine. These two are important. Fine. Now I have to proceed ahead for the project session. Let me